Up, nerds? It's me, also nerd. I made a number system called the Zooneian number system because I call myself Zoonie6, therefore the Zooneian number system. As I've written, it has a base of 48 with sub-bases of 3 and 4. Two separate sub-bases. There's no like sub-base. But the thing is, you only really need to learn like 5 symbols to use it. So, let's. I'm just gonna share my creation with you now. Okay, first off, we got 0. 0 is nothing special. It's just, a no sign, I guess. It's 0. And then we got 1. And also, they all have their own names. And also, I should probably write down their numeric value in, Hindu Arabic numerals in base 10. So, our 0 is called null. Yeah, null. And our 1 is called un. Our 2, which is 2 strokes, we got 1 stroke, 2 stroke, is do. Also, I could write that one better. So we got null, un, and do. And then true. New, do, and true. That's our 1 through 3. And then our 4 looks like that. And it is called ert. So now from here we take 1 and we take 4, and that's 5. See, we have our 2 sub-bases, 1 of 3 and 1 of 4. This is called, wait, it's actually pronounced nwert with like a W. I wanted to make all of them 1 syllable long. I probably should have went with 2 syllables long, but it always bothered me how 7 is 2 syllables long, well, every other single digit number was 1 syllable long, except for 0, but that one you could just say ot or o. So that one didn't bother me much, but yeah. So we got nu, do, true, ert, and nwert. And then I think you can tell how this goes from here. And so yeah. Most of the time when writing them, I'm just gonna like pause the video to write all of them, because you get the concept. We have our triangle and we have our inner parts. Their technical names will be pneumajigs and ertajigs. That's just what they're called. Yeah. So, continuing, now that we have to go to 8, we have 2 4s, and that is called oct. And then we go through a similar process. I'll just pause the video and write them down. So, now that we've gone to 2 erts to make octs, that's not what I'm gonna have done anymore. I'm now going to make a new symbol. There. That's our new symbol. It's just a sideways ert. and it is called wit. It's called wit. So I'll just pause again. Okay, so now that we have wit, next we need to get to our one for 16, and we will take a wit, and we will take an ert, and then there we go. And this one is called Iggs. Yep, there you go, Iggs. So, yeah. So the next one is pretty simple. Yeah, there you go. 4 plus 4 plus 12. So, this one is called Idge. Like, Vigintillion. Idge is 20. Yeah. Okay, I went ahead and wrote a lot of them because it was probably pretty obvious on what was going to happen next. But I'll still list off their names. So, I believe we left on Iggs. Well, no, we left on Idge. So, yeah, Idge is 20. So, 24 is Urk. Yeah, Urk. So we got Nurk, Dwerk, and Twerk. I probably should have thought of that before I started naming one of them Urk. Anyway, so then we got Ivg. We got Ivg because why not? We got Ivg for 28, and Nwivg, Twivg as always. And then we got Ebe. And we got Nweeb, Dweeb, and Tweeb. Hey, another one that sounds like a word. So next, worth 36, we got this curvy boy named Olsh. So yeah, and then we do what we expect. I will pause, and then after we got a bunch more, I will talk about them. Okay, I've written it all the way up to when the place value changes, because it does work like Hindu Arabic numerals in that way. So, we got Ivg, I believe we left off there. Oh no, we left off at Olsh. So we got, Olsh, and then we have Ek, and then we have Uf, making Nuf, Duf, and Truf, and then we just say each digit by, out loud. New null is 48. So, you may have noticed that I left half the board empty. I'm gonna show you why. Okay, cool, I had to change markers because it started to die, as you can see, but, when you flip them upside down, you get the negative numbers. Urt has gotten a beating anyway. I will mention that all of the negative numbers that ended in I end in the sound E, not I. So it's G, and it's ski, not giant sky. So, yeah, that's about that, except I did some cool stuff with math symbols, and also I know I had another row, but I think you get the point. So, I'm going to show you how the new math symbols work. Okay, so here are our new math symbols. The equal sign lost a line. Now, seeing as negative and positive numbers have their own symbols, plus and minus don't need separate ones, so we just have this one. And it's actually, the reason I chose the plus sign specifically is because it cannot turn 90 degrees, because as you can tell, everything else gets their opposite by turning 90 degrees. We have multiplication with the old division symbol, because I can't have a bygone unless we're on a sphere. And then we have a 90 degree rotated division symbol for what the old division symbol did. I shouldn't really call them new and old, because it's not like this one is replacing Hindu Arabic numerals. It's just something I made in my free time for fun. So exponents now also get a symbol rather than just being tiny and to the right. They have a symbol just like the four operations. And roots is turned 90 degrees as well. And we have tetration. I don't really know what the opposite of tetration is called. And we got pentation, hexation. I put dots because you get the point. We just put the polygon of whatever the number is. So our roughly equals, once again it just lost a line. Greater than and equal, greater than and less than have not changed. Not equal to, once again lost a line. And I just did that to equal or less than or equal or greater than, just because. But something I would like to make note of. So in the worldwide global number system, Hindu Arabic numerals, we use a symbol to show that we don't know if something is positive or negative. It's the symbol I used under the plus/minus sign. And I still wanted a way to do that, so you put that symbol over a number and we don't know whether it's positive or negative. I would have just had, instead of turn them, right side up or upside down, turn them sideways, but then ert and wit would not be distinguishable in between, well, is it positive or, just we wouldn't know. So instead we put this symbol over a number, like there. We don't know if it should be positive or negative. And, sometimes we put a minus sign above a plus sign to say, we also don't know this one, but we know it has to be the opposite of the one that has the plus negative sign. So to do that, to show that it can't be the same as whatever this one is, we just make it negative. And so that's the version of, this and this when we just don't know. So yeah, that's about it, but there are some interesting things about the system I would like to show. Okay, so I wanted to talk about the skip counting. I'm not going to talk about counting by 1 because you already saw that. I'm not going to talk about counting by 2 because it's simple. You just never have a numajig at the bottom. That's how you tell if something's an even number. I'm not going to talk about counting by 4s because you just change the ertmajig by 1. And you just never have any numajigs at all. Because remember, numajig was the technical term for the outside triangle, and ertmajig was the technical term for the multiple of 4 inside. So for counting by 4s, you just never have a numajig. But counting by 3s is interesting. So right here we do have our 3, 6, and 9. But here's the thing. We always go down 1 numajig unless we have no numajigs. Then we always go down 1 numajig and then loop around. When we have no numajigs, we loop back around to 3. And we always go up by 1 ertmajig unless we have no numajigs. If we have no numajigs, then we stay at the same arithmetic when we add 3. And that's just how it works. There's a pattern, a simple, easy pattern. And I would say the reason we get rid of one numajig is because 3 is 4 minus 1. And I think this will be proven with how counting by fives works. So here's some counting by fives, and as you can see, we always go up by one unmajig. So, yeah, as you can see, we go up by one unmajig, and then we flip back to 0. But when we flip back to 0, instead of going up by one arithmetic 2, because we are also always going up by one arithmetic, except when we are at 3 unmajigs. When we're at 3 unmajigs, we go up 2 arithmetics. That is, we add 8 to the center number, the center multiple of 4. So, yeah, and it just continues like that for the whole thing. It's interesting. Okay, so counting by sixes, which is what we have here, has a slightly more complicated pattern. So we go 3 without any numajigs, then we have 2 numajigs, then we go 1 with no numajigs, then 1 with 2 numajigs, and then we go back, then 1 with no numajigs again, then 1 with 2 numajigs, and then 3 with no numajigs. And this is a pattern. We go 3, 1, to go the amount with no numajigs, we go 3, 1, 1, 3, 3, 1, 1, 3, indefinitely. And of course, when we have numajigs, we only have 2 numajigs. So that's the pattern for sixes. I thought it would be fun if I showed each base's each number system's first 3-digit number in the other one. So the Zooneian in number system, its first 3-digit number is obviously nu null null, which is equal to 2,304. But 100 is only equal to do ert. Yeah, that's the difference we're talking here. So, yeah, I would show more skip counting, but the longer and longer we go on, the less and less patterns there's going to be. But, I can teach you the basics of addition if you want. So here is a basic addition / subtraction problem, but they're both positive, so it's addition. And also that's part of why the equals sign is one line. It's the same vertical and horizontal. Anyway, so the first thing we do is we add the arithmetics. And we know that it would simply be this one plus this one. Wow, who would have thunk? And then we add the unmajigs. And we have more than 3, so we then put 4 of them into one more arithmajig. And then we will have 1 remaining. That is our answer. So, twirt plus, I'm not remembering the names right now. I don't usually use the names when using it or talking about it, but it's, very easy to do math in. I'll write the answer a bit bigger, same size as the other ones. That's our answer. It's not hard. Then you go into place value and all that. It's simple. Maybe sometime in the future I'll make a part 2 where I go through the skip counting of every number, but I didn't put it in this one because people would find that boring, including me. Anyway, so yeah. Oh yeah, and I did forget to mention, but the decimal point stays the same. No, nothing changes there, except it's not decimal anymore. I would say what it is now, but I don't know the name for 40 and that kind of thing. It kind of stops at 20 for me. Vigintillion, that's kind of where it stops for me. I don't even know 30. But I do know that when you get past what is essentially 999 alien, you add another alien, so you'd get million alien. And that's fun. So yeah, that's the video. Shalom, God be with you, and before you watch another YouTube video, do something nice for someone. You were made in the image of God to do good, so you can do good. I believe in you. You can do it. 2 + 2 = fish.